Good morning, class. Today, so it's calculus. I know, it's a school closure period of time, so we need to stick with all this lecture, and you still need to do the homework daily through the lesson that I cover on the YouTube channel. So especially for block 1, block 2, well actually all my classes. So this one is the video for calculus 3.7. Okay, so we'll take a look at that, the rate of change today. Okay, so for the rate of change, so record out the average rate of change. The way to find it is by using the slope formula, which is y2 minus y1 over x2 minus x1. So that equals the slope. And the instantaneous rate of change is basically just the derivative, which is f prime of a. As you can see, that a is right here. Okay, so that's the instantaneous rate of change. We can use the general definition of limit to find the instantaneous rate of change, or we can use that derivative formula for each type of functions. Again, the general formula is that limit as x goes to a, and then f of x minus f of a, so over x minus a. And back to geometry or algebra 1, if two lines are parallel, what happens with the slope? The slope, they're always considered exactly equal to each other. Okay, so two lines are parallel, the slope must be exactly the same. Okay, so now let's see what we got for the next slide. So here's one of the word problem. So a particle moves according to the law of motion. So this one is not just about calculus, it's also talking about the physics. So law of motion. So let s equals f of t, which is the position, and then t is greater than or equal to 0, where t is in seconds, and the distance or the position s, it's in feet. And then find the velocity at time t. So velocity, that means basically we just take the derivative of the position function. Okay, so let's find out the first one. So derivative, then that will be considered f prime of t. So the function that we have is t to the power of 3, so we do have derivative, which is 3t squared. And then minus derivative of 12t squared, so we do have 24t. And then plus 36. And then the next question, when is the particle at rest? So think about it this way, if the particle at rest, what happened with the velocity? So that means the velocity got to be 0, so we set it equal to 0, and then we solve for t. Okay, so the way that you solve for t, you can just factor it, and then solve for the variable. So we try to factor, so we take out 3 first. So we do have t squared minus 8t, and then plus 12. So that equals 0. So we got 3 times, so factor the trinomial, we can do it mentally, so it's t minus 6, and then t minus 2. So that means at t equals 2 seconds and 6 seconds, that means the particle is at rest. And when is the particle moving along the positive direction? So if that's moving to the positive direction, that means we want to do the first derivative, the line test. Again, at 2 seconds, well, the initial time is what, 0, and then at 6 seconds, so the particle is at 0. So you want to plug in any number that it's run between 0 and 2. So let's say that you plug in 1 here, back to the first derivative. So we got 1 minus 6, which is negative 5. 1 minus 2, negative 1, so negative times negative, positive. So that means the velocity is positive. And then number run between 2 and 6. So let's say that I plug in 3. So 3 minus 6, that's negative. 3 minus 2, positive. So positive times negative times positive is still negative. So that means the particle is moving to the left. And now let's find out the velocity, anything that the time is greater than 6 seconds, so 7. So 7 minus 6, we do have 1. 7 minus 2, 5. Positive, positive, positive. It's all positive. So that means the particle is moving to the right. The time for that would be from 0 to 2 seconds, and also from 6 to infinity. And then the particle, it's moving to the left. And that's the time for this. That'll be from 2 to 6. And then find acceleration. Acceleration, that means you want to find the second derivative. So let's find the second derivative. So we do have 6t, derivative of first derivative, minus 24. And now you want to find out the acceleration at 3 seconds, so we plug in the time. So we do have 6 times 3, which is 18. And then minus 24. So 18 minus 24, which is negative 6. And the unit for this one would be feet per second square. And then for E and F, you want to find the total distance during the first 8 seconds. So find the total distance. So that means, so you want to find out the positions. Okay, so from 0 to 2, and then from 2 to 6. And then whatever the distance that you find out, you just want to add them all together. So again, during the first 8 seconds. Okay, so I need more space for this one here. Okay, so let's see. Well, let's find out the position at 0 second. So the position is 0 seconds, so the position would be at 30, it's going to be 0. And then the position at 2 seconds. So we plug in 2 back to the original functions. So we want to find out the position there, and then you want to subtract. And then after that, you want to plug in that 6 back to the original functions, and then 8. Okay, so now let's plug in 2 here. So we got 2 to the power of 3. That's 8. 2 squared, that's 4. So it's negative 48 times 12. So it's negative 48. So 8 minus 48, that's negative 40. And then 2 times 36. So then that'd be 72. So negative 40 plus 72. Okay, so which is consider, okay, so it's going to be positive number, which is negative 32. And then we want to find out the position at 6 seconds. So it's 6 seconds, because that is 6, the particle is at rest. So again, plug in the time and then find out the position at that moment. So for that one, also you end up with a positive number. So it's better for you to do that on the calculator and see what happened. So once you get that positions, and then you want to plug in 8 to get that positions. So you get all the distance. Once you get all the distance, you just want to combine them all together. Okay, so let me open up the new slide for this one. Okay, file. So you want to find out the position at 0 seconds, so obviously 0. At 2 seconds, okay, so the one that we found, which is 32. And then you want to find out that at 6 seconds. And then you want to find out that at 8 seconds. So the distance from 0 to 2, so the distance would be 32. And then for 6, so you want to find the distance from 6 to 2, you want to subtract those two distance, and then you get a number. So let's say that the distance here is 48, so you want to subtract those two, so you'll get 16. And then the position here, so let's say this one is 96. Well, this one is just for example, okay, 48, 96, subtract, then you'll get 48. So all the distance, so you just want to combine them all together. So 32 plus 16, 48, 48 plus 48, which is what? 96 feet for the total distance from 0 to 8 seconds. Okay, so now let's see what the next question is. So when is the particle speeding up? Slowing down? So we did the first derivative line test, and also we need to do the second derivative line test, okay? So let me go back to that, the new slide here. So we did the first derivative, the line test. So at 0, 2 second, 6 second. Again, this one is the first derivative, it's just the velocity. And now you want to do the second derivative line test. Acceleration. And also for this one, you want to set that the second derivative equal to 0. So set the second derivative equal to 0, so you get t equals 4. Okay, right here. So you get t equals 4. So you set that this part here equal to 0. So set that second derivative equals 0. So we got t equals 4. Okay, so t equals 4. Again, according to the first derivative line test, so here's what we got: positive, negative, positive. Okay, so positive, negative, positive. And now you want to do the second derivative line test again. So the second derivative line test, you do have 16 minus 24. Okay, so 16 minus 24. So plug in a number, any number right between 0 and 4. So we got 1. So 1 times 6, that's 6. Minus 24, so it's negative 18. So it's negative. And then plug in any time that's from 4 to infinity. So we do have 5. So 6 times 5, 30. 30 minus 24, that's positive 6. So it's positive. So in order to find out the time interval where the particle is speeding up, so that means they do have the exact same sign change for the velocity and the acceleration. So the exact same sign change. So let's take a look at that here in the middle. So it looks like from 2 to 4, so they both have the exact same sign change because they're both considered negative and negative. So that means the particle is speeding up. And the time interval for that is from 2 to 4 seconds. And also from 6 to infinity, and also they do have the exact same sign change from 6 to infinity, because that they both consider positive and positive. Again, the reason why it's 2 to 4 because that velocity and acceleration, they're both considered negative and negative. And then 6 to infinity, also they do have the exact same sign change, positive, positive. So now, when is the particle slowing down? So for the time interval, if the particle is slowing down, that means they do have the different sign change from 0 to 2 seconds. Because this one is positive, but this one here is negative. And what else? Anything that from 4 to 6. Again, this one 4 is positive for the acceleration. And anything that up to, well, in between 4 and 6 is negative. So from 4 to 6. So that's when the particle is slowing down. Okay, so if you do getting stuck with anything like this, make sure that you need to rewind the video and then just watch that, what I just talked about previously. Okay, so now let's go back to the template. So now here's the next slide. So record out the standard form of a quadratic function. So y equals ax squared plus bx plus c. So anytime they see like a vertical motion position functions, so you see that negative 16t squared plus v naught t plus s naught. Negative 16 is called the gravity on Earth, which is considered negative 16 feet per second square. And then t is just a time. Again, t is just a time. And then v naught is just the velocity of the object. And then s naught is considered the initial position or the initial height. Okay, so now let's use this model to solve for the next problem. So here's the one. If a ball is thrown vertically outward with a velocity of 80 feet per second, so this one it's v naught, initial velocity. And then its height after t second, it's considered 80t minus 16t squared. So what's the maximum height reached by the ball? So this one's a quadratic function. You can use the vertex formula for this. Obviously, you can do that. But in calculus, would you know that if the ball reached to the maximum height, so that means the velocity, it's always considered 0. So the slope is 0. So that means the position function, we can use that to take the derivative, and then we find the velocity. So derivative of 80t, which is 80, minus derivative of negative 16t squared, so then that would be negative 32t. Again, we do know that once the ball hit the maximum, the velocity is considered 0. So we set it equal to 0, and then we solve for the time. So for the time, we do have 80 divided by 32. Try to separate it. So 80 over 32, it's not divisible, so you want to reduce it. So this one is considered 10 over 4 divided by 8 time at the bottom. Reduce that again, so we do have 5 over 2. So it's 2.5 seconds. So at 2.5 seconds, so that means the ball is going to reach to the maximum height. And now what's the velocity of the ball when it's 96 feet above the ground on its way up, on its way down? So that means you want to set the position equals to 96. So 80t minus 16t squared. And then from here, you want to solve for t. Again, it's a quadratic function. You want to bring everything together to one side. So we do have 16t squared minus 80t plus 96. So that equals 0. And you can always take out the greatest common factor. So it looks like the greatest common factor for this one would be 16. So we left with t squared minus 5t and then plus 6. And then for the trinomial, you want to factor it. So once you factor it, you do notice that is t minus 3, t minus 2. Again, set that equal to 0. So we do have two time. One is at 2 seconds, and the other one is at 3 seconds. So for those two times, so you see that the ball is reaching to the 96 feet. Again, it's a parabolic figure. So at 2 seconds, so the ball reached to 96. And then at 3 seconds, and also the ball hits 96. Okay. So now let's see what else that we have. So here's another typical problem for engineering. It's for electrical engineering. So for those people who want to major in double E's, so here's what we got. And the quantity of a charge Q in columns, so the unit C, so that has passed through a point in a wire up to the time t in seconds. And it's given by the functions Q of t, t to the power of 3 minus 2t to the power of 3 plus AT plus 4. And now you want to find the current. So the way to find the current, so basically this one is just finding the derivative of the column, the charge. So first thing that you want to do, you want to take the derivative. So Q prime of t. So we do have 3t squared minus 6. Well, this one there's a typo here, so this one's supposed to be a square here. Okay, let me fix that. So the function is given by t to the power of 3 minus 2t squared. So again, derivative of negative 2t squared, so we do have negative 4t so minus 4t, and then derivative of 8t, which is what? 8. So once you get the first derivative, just plug in the time. So 1 second, 2 seconds. So you'll find out exactly what that is. So plug in the time to find out the current. So the current usually is considered column to unit. It's column per second. Okay, so the current going to the circuit. And at what time the current is the lowest? If that's the lowest, so that means you want to find out the second derivative. because the second derivative, that just represents the velocity of the current. So it's 6t minus 4. So the lowest, so that means the rate of change for this one, it's always 0, because that's the lowest. Just like the parabola, so the lowest position, the velocity is always 0. And then we solve for the t, so t equals 6t equals 4. That means t equals 4 over 6. And so that means the time for that would be 2/3 second. So again, the way to find a current at those times, so once you get the first derivative from that charge, Coulomb, and then you just plug in the time and then just evaluate it, and then you'll get the current at those times. Again, any questions, any concern that you have, feel free to put up the comment questions on the YouTube bar for the comments, or you can send me the email through Schooloop. Okay, so thank you for watching the video today, and make sure that you complete the homework tonight, and this one is for sections 3.7. And when is this one due? So all the homework is going to be due by the time that when the school hour got reached soon. Okay, so far we're going to be taking a break for 2 weeks, probably 3 weeks, we don't know. Okay, so due to the COVID-19. Okay, so thank you for watching the video again. So I'll see you next time.